Okay, welcome back. This is part 2 of the video. As I mentioned, we'll be discussing things such as multiplicity, factoring to find zeros, and turning points. Now, first thing we want to look at is let's just use factoring to find zeros first off. This is what we've got. We've got f of x equals x cubed minus 4x squared minus x minus 4. And we're wanting to find the zeros here. Well, this will factor, and we can do factoring by grouping. It's something you learned in Algebra 1, but you probably did not spend a whole lot of time on. But factoring by grouping just says, hey, let's take these first two and these last two and group them together. I'm going to put a plus in between there because it's not being multiplied. But we're going to add these together. But first off, we see that there are common factors in here. First off, as far as common factors are concerned, we have an x squared in common with both of these. So let's factor out an x squared. And when we factor out an x squared, we're left with x plus 4. And then in this last one, notice I still have the plus in front here. I didn't want to put a minus here because if I put the minus here, I'd have to change both signs. But I'm going to end up factoring a negative out. So let's factor out a negative 1, and we would be left with negative 1 times what gives me negative x. That would be positive x. Negative 1 times what gives me negative 4, and that would be positive 4. So we have factored by grouping, and we have a binomial as our result. And in this binomial, both parts of the binomial have an x plus 4 in common. So we're going to factor that out, so we get x plus 4 times x squared minus 1. And then from there we can factor, and we see that we get x plus 4 times x plus 1 times x minus 1. And this is how it factors. Now, you know from the past, to find a 0 here, what you would do is set each portion equal to 0. So we would see we'd have a 0 at x equals negative 4. I can make that neater for you. X equals negative 1 and x equals positive 1. So these are going to be where my zeros are going to exist. Now, looking at this, we've got negative 4, negative 1, and then positive 1. Those are going to be my zeros. Now, let's talk about what this graph does. It's an odd degree polynomial. So from the last video, we talked about in an odd degree polynomial, you would start low and end high if that first term was positive, which it is positive 1. So we're going to start low and end high. So we're going to start here, and we're going to cross here. We'll come up and we'll cross here. Now, it's going to cross somewhere right in between negative 1 and positive 1. It's going to cross the y-axis. Well, again, every point on the y-axis has an x-coordinate of 0. So if we plug in 0 to the original equation, we get 0 plus 0 minus 0, then minus 4, so we get negative 4. So it actually goes all the way down to negative 4. And it comes back up. So that's going to be our graph. Now, there are a few other things about this graph. The next thing we're going to talk about is the turning points of the graph. To find the turning points of a graph, what we do is we look at the degree of the polynomial. And this degree is 3. So to find the turning points on the graph, we take the degree and subtract 1 from it. So we would have 3 minus 1, which is 2. So what this says is not necessarily that we have 2 turning points, but we will have 2 or fewer turning points. And in this case, we do have exactly 2 turning points. The graph increases, then the turning point refers to hey, I changed from increasing to decreasing, or I changed from decreasing to increasing. So I'm changing from increasing to decreasing. That's one turning point. Then I changed from decreasing to increasing. That's my second turning point. So this one had exactly 2 turning points. So to determine the number of turning points, we take the degree of the polynomial. In this case, it was 3. Subtract 1 from it, and we get 2. Now, there's one other thing that can happen in these problems, and this is called its multiplicity. To look at the multiplicity, we look at the final function after we have reduced it all the way down into its factors. Each one of these has a degree of 1. So each one of these factors has a multiplicity of 1. Now, because it's an odd number multiplicity, that means that the graph is going to cross the x-axis at those points. So if you look at negative 4. It crossed at negative 4. It crosses. The graph crosses at negative 1. The graph crosses at positive 1. So, because each one of these is an odd number, the graph crosses the axis. So let's look at one where we have a multiplicity that's an even number. So let's take f of x equals x to the 5th minus 9x cubed. So here we're going to factor to find the zeros. So I'm going to factor out an x cubed. So it'll be x cubed times x squared minus 9. So we get x cubed times x plus 3 x minus 3. Okay, I was wrong here. This is actually going to have an odd multiplicity for each one. But this multiplicity of 3 here, because remember what x cubed is. X cubed is the same thing as x plus 0 cubed. So we have a solution of 0, negative 3, and positive 3. Those are going to be my zeros. Now, the other thing here is we're going to have solutions here, or zeros, or roots. Again, all those terms are interchangeable. This x to the 5th term is a positive number, so it's a positive number. It's an odd multiplicity, so it's going to start low and then end high. Now, we're going to cross the x-axis here at negative 3. Then we're going to go up, and then we're going to come down. Now, because it's an odd multiplicity other than 1, it's going to do a little funky little turn right here. It's still going to cross there, but it's going to act like it doesn't want to cross at first, but then it's going to end up crossing. In calculus, you would learn that to be a point of inflection. But then it goes on down, and then it comes back up, and it goes on forever. So this is what we're looking at as far as the solution is concerned here. That will do it for this video. I'll have one more video, and then you will have your homework.